The Best of Our Knowledge explores topics on learning, education, and research. Coming up, sea ice in the Southern Ocean is melting, leading to increased ocean heat loss and stronger storms. We'll speak with a climate scientist to learn more. And New York's largest teachers union is backing a proposal to ban cell phones in classrooms across New York. I'm Lucas Willard, host of The Best of Our Knowledge. You're listening to The Best of Our Knowledge. I'm Lucas Willard. Antarctic sea ice is melting. The Southern Ocean has an important role in mitigating climate change. If sea ice keeps disappearing at its current rate, it can cause unfortunate outcomes for both humans and wildlife. A study published in December shows record low sea ice in 2023 led to an increase in ocean heat loss and stronger storms. To learn more about sea ice in the Southern Hemisphere, The Best of Our Knowledge's Madeline Reynolds spoke with Dr. Laura Landrum, a project scientist at the National Center for Atmospheric Research in Boulder, Colorado.
Sea ice is ice that forms on the ocean. It's from ocean water that forms into ice. It's differentiated from land ice, and that land ice forms like glaciers or from precipitation and freezing on the land, whereas in the ocean, it's ocean water that's freezing. And one of the important things to note, which I'm guessing we'll get to a little bit later in this, is that when ocean water freezes to make sea ice, it rejects some of the salt that's in the ocean. So sea ice is still almost fresh water. It's really fresh compared to the ocean. And that salt that's rejected out of that sea ice then makes the water just under that sea ice really salty and makes it heavier. So sea ice is formed from seawater.
What is the function of sea ice in the Southern Ocean, and what is its importance?
It's important for many reasons and from many different aspects. From an ecological perspective, it provides protection and access for marine predators and fish. So penguins, for example, will use sea ice. Different species of penguins use sea ice for different things, such as access to their prey, fishing, and they also use it, some of them, for hatching and breeding and mating and raising their young. Sea ice can also be a way that some animals or marine animals can be hidden from above, so they can kind of hide under the sea ice. It plays a very important role in the marine ecology from the what we call kind of base on up. In that sea ice, in the winter, the sea ice covers a lot of region that's also really dark. And as the Southern Hemisphere gets more sun, approaches the summer season, and that sea ice melts, when the sea ice melts and the sun comes up, it exposes water that was not exposed before, and the plankton often take off dramatically. And we have these regions that show tremendous phytoplankton blooms. You can see them from space. So satellite pictures of the regions around Antarctica will show ocean areas that look a lot greener because they're having a massive phytoplankton bloom. And that phytoplankton, that in turn, then feeds the whole ecosystem around Antarctica. And some of those ecosystems are some of the most productive in the world. They're just kind of amazing. So in an ecological perspective, it's important. Sea ice also modulates heat exchange. So it influences the heat exchange between the atmosphere and the ocean. And when the atmosphere is really cold, like below freezing, like it is in the Southern Hemisphere in the winter, the ocean, if it's open and exposed to the atmosphere, will lose heat to the atmosphere and form sea ice. If there's sea ice on top, it acts like a blanket and essentially insulates that ocean, the warmer ocean, from the colder atmosphere. Sea ice also functions as it reflects radiation. It has what we call a high albedo, and that means that a large amount of the incoming radiation from the sun is reflected back off if you have sea ice in an area that's getting sun. This plays a really large role in the Arctic sea ice, for example, but it also does in the Antarctic. And that reflected radiation then goes back out to space and doesn't warm up the planet as much.
And in the research, according to it, before and up to 2014, sea ice in Antarctica was showing small but significant increases. However, after 2014, it has been followed by large losses, specifically in the years of 2016, 2023, and 2024. Is there a specific reason for that?
Yeah, that's an area of very active research. The slight increases in sea ice up until about 2014 over the satellite record, which began in 1979, the period at which we can see sea ice using satellite images. So that slight increase was is a little bit of a puzzle for us, because you think that the globe is warming, and very definitely is warming. So how are you getting increases in sea ice in Antarctica in a warming world? That seems like a contradiction. Now, these increases were actually quite small and very regional in nature. And the Ross Sea, for example, showed the greatest increases in sea ice during the austral fall. So when the sea ice was expanding, and slight increases. So we think that some of this has to do with ocean circulation and small amount of variability. Now, Antarctic sea ice is really different than Arctic sea ice in many ways. In the Antarctic, you have the continent of Antarctica, which is surrounded by ocean. And that ocean has a very strong current, this circumpolar current that goes all the way around the continent. And that current in itself serves as a boundary for how far north or equatorward the sea ice can expand. And then in the summer, the sea ice around Antarctica melts back and retreats back to the coast most places around Antarctica. There are some year-round sea ice areas in the Ross and the Weddell Sea, but for the most part, elsewhere, the sea ice melts completely back to the continent. This is very different from the Arctic, which is an ocean surrounded by continents, and those continents serve as the limit to the maximum winter ice. And in the summer, it just retreats until, as based on temperature, it doesn't retreat entirely, and we still have year-round ice in the Arctic. So this slight increase in Antarctic sea ice is still not completely understood. And we have some different theories. We think some of it may be circulation in the ocean and the atmosphere that have made the regions, particularly the Ross Sea, increase a little bit. And then we saw massive decreases, particularly in 2016, and then again in 2003 and 23 and 2024. The 23 and 24 decreases, what was really different about those is that they occurred in the winter, in the southern hemisphere winter. And that is surprising, to have a sea ice loss in the winter, because the wintertime atmospheric temperatures are still really cold. They're well below freezing, often like 10 to 20 to 30 degrees Celsius below zero, which is about 14 degrees Fahrenheit to minus 25 degrees Fahrenheit below zero. So you can imagine that decrease in sea ice is not because of atmospheric warming. It can warm a little bit, but it was definitely below freezing. So it must be due to something happening elsewhere in the system, whether it's a transportation of ice or warmer waters underneath it. It was just those losses were significant and much larger than any annual change that we've seen in the southern hemisphere over the satellite record from 1979 until now.
And with this ice melting paired with the oceanic changes, the research suggests there's a shift in the southern oceans. Unlike anything seen in the past century, what is this shift?
Well, what we think is maybe happening is that the circulation of the Southern Ocean may be influencing it in a way that it hasn't before. And the shift that we're referring to is that, first off, the change in the Antarctic sea ice, it became much more variable after about 2016, meaning there were much bigger differences year to year, and these just massive losses of sea ice that we have not seen that cannot be explained by atmospheric temperatures alone. They have to be connected to circulation and ocean temperatures. Now, sea ice plays a very important role in what we call the global thermal haline circulation, or the circulation of the ocean below the surface. And surface water of the ocean, when it gets dense enough, so heavy, it can sink, and it can sink. There are two places in the world where it sinks to the bottom of the ocean, and one is in the North Atlantic Labrador Sea area, and the other is in multiple regions around the Antarctic coast. When sea ice forms, it leaves a really salty, cold water behind. Salty water is heavier than fresh water. Cold water is heavier than warm water. So it's salty and cold, and as it flows down over the continental shelf, it mixes with water that's at mid-depth that is actually fresher than it and warmer. And when they mix together, the new water itself becomes even more dense because it gets saltier and becomes the densest water in the world, and it sinks to the bottom and flows around the bottom of the ocean. Now that circulation of water forming at the surface of the ocean that becomes heavier and sinks to the bottom is critical for understanding how much carbon dioxide that is emitted to the atmosphere will be taken up by the oceans and how long it will be sequestered or removed from the atmosphere. Now, that deep water circulation, it takes on roughly 1,000 or more years before water that sinks around Antarctica to the bottom of the ocean and flows around the bottom of the ocean and eventually comes back up. And it carries with it the signal of the atmospheric components, carbon dioxide, etc. When it was exposed to the atmosphere, it carries that away. Well, these massive changes in Antarctic sea ice suggest that something different is going on in the circulation around Antarctica in the past few years compared to the satellite record of the past 50-some years. And we don't really know exactly what's shifted. It's, as you can imagine, in Antarctica, particularly in the winter, it's really hard to take observations. We have satellites that can take images, but the weather and the cold and so a long ways away from any ports of call, the safety, it's hard to get measurements of ocean water with depth, for example. So we do have some, but we don't have enough data over the past 50 or even 100 years would be wonderful, but we obviously don't have that. So we can look at things like changes in sea ice and make some estimates of what's happening, but we don't honestly know exactly. We have some good ideas, but it remains to be seen. So we think there may be a switch or a change in circulation patterns and therefore heat transportation by the ocean and the atmosphere in the southern hemisphere.
You're listening to The Best of Our Knowledge. I'm Madeline Reynolds. In case you're just joining us, I'm speaking with Dr. Laura Landrum, a project scientist at the Center for Atmospheric Research in Boulder, Colorado, about Antarctic sea ice. And just how dominant is the Southern Ocean in mitigating global climate change, and why?
It is extremely important, and a significant part of the carbon dioxide, about 43% of the carbon dioxide that's been emitted into the atmosphere from the burning of fossil fuels has been taken up, and also 83% of the heat. So water, the ocean water, when it's in contact with the atmosphere, will take up chemistry from the atmosphere until it comes into equilibrium, and also heat, warm or cool, depending on whether or not the atmosphere is warmer or cooler. And the ocean around the Southern Ocean has taken up just a little bit less than half of the carbon dioxide that the ocean as a whole has taken up around the globe. So about 43% of that oceanic uptake of carbon dioxide has occurred in the Southern Ocean. And it takes it up, and then that water, when it forms and sinks, it carries it away from the surface. So it's extremely important. It also has taken up a lot of the heat. So in terms of a big picture of changing climate and increasing fossil fuel burning and CO2 in the atmosphere, the Southern Ocean plays a very large role in how the Earth responds, the Earth's climate responds to increasing CO2 in the atmosphere.
Are there any prominent glaciers in the Southern Ocean or near? Could these potentially be affected? And if so, what would happen?
So there are glaciers on Antarctica that feed into the Southern Ocean, and there are permanent ones, large ones like the Thwaites and Pine Island glaciers, and they skirt the Southern Ocean. They're on that continent, and they flow into the Southern Ocean. Now, it turns out water can melt ice a lot faster than air can. Just think of if you pour warm water into a glass of ice cubes on a hot day, let's say it's 90 degrees out, and you've got a glass of ice cubes, and you set one glass of ice cubes out just by air, and another glass, and you pour 60-degree water in it. Those ice cubes are going to melt a lot faster in the water than they are in the air. So water has a heat capacity. It can melt ice much faster. And some of these glaciers along Antarctica, and particularly the Thwaites, the Pine Island, their front sides and their tongues that go out into the ocean are exposed to ocean water. And if that ocean water warms in temperature, it will melt them faster. And there are concerns that some of these glaciers are melting very rapidly because of the contact with the ocean water, relatively warmer water from below. All the ocean water that is still water is above freezing. When it freezes, it becomes ice and goes to the surface. And water below the surface is above freezing in temperatures. And as it encounters glaciers, it can melt them. And if that water warms and that circulation warms, it can have an impact on southern hemisphere glaciers, the Antarctic glaciers, which has tremendous implications. The potential to change could cause catastrophic sea level rise.
With the sea ice melting, it leads to ocean heat transferring to the atmosphere, causing open circulation, which you've kind of touched on a little bit before. Does this cause more storms? And if so, what kinds?
It can make it more stormy. So storms need energy to form, and usually we think of it as like inputs of moisture and heat and some wind to get things kind of moving. And when there's sea ice on top of the ocean, it once again serves as kind of a blanket between the warmer ocean and the colder atmosphere in the winter. Now, if that ice is gone in an area that used to have ice, and it's gone and that open water is exposed to the atmosphere, you will have heat loss because the water is warmer than the atmosphere, and you'll have heat loss to the atmosphere. And you'll also have moisture loss because warmer atmosphere can absorb more moisture. And the winds around Antarctica, there's always some winds. You're going to get some atmospheric movement. And that will lead to an increase in the storminess in areas that are newly open and not ice covered, particularly in the winter.
So how does the sea ice melting affect the marine life, ecosystems, and even the predators that rely on this ice?
So it depends on which predator, but sea ice melting, a reduction of sea ice for emperor penguins, for example, gives them less of a platform for both their breeding and raising of their chicks, and then that changes the distance they have to travel to prey. It can also change the location. Now, I'm not a biologist, so you may have to get a biologist to refer to all this. I think there are some other penguins that require sea ice in order to nest and to have a successful hatching and nesting. If they don't have any sea ice, I think that's the emperors, then they won't have a breeding success rate. Likewise, if you have the sea ice retreating, the distance to where they have to go to be successful at getting fish might change. And if you get a longer distance, then you're going to make it harder for them to get the fish. There are likewise seals that use the sea ice around Antarctica, like southern elephant seals. They use it for resting and kind of a nursing and calving ground for their babies. And if the location of that edge between the sea ice and the ocean changes, there's the risk or the possibility, I would say, that their location to their prey as well might change. And then you also have a timing of the phytoplankton blooms in the spring. So if you have an area such as the Ross Sea has a lot of places in it where it gets these really huge phytoplankton blooms where the sea ice retreats when there's solar light available, when it's sunny, or the sun's shining in the summer, and it retreats. And when it retreats, suddenly this water that has accumulated some nutrients over the winter is exposed to light, and the plankton, they just kind of take off. Now, if that sea ice starts retreating earlier and earlier, it's possible that you will change the timing of when that ocean water gets light. It can be determined not by sea ice, but rather when the sun comes and hits open water, and you can get different types of plankton thrive in different types of timing and light availability. And you may change the timing of the bloom, or you may change it from one size of plankton to another, and then you change kind of the food webs and what is available. So it changes things.
And then my last question for you is, what sort of global ramifications can result from all of this if sea ice keeps declining?
The Antarctic sea ice keeps declining. It will have an impact on ocean circulation, particularly Antarctic bottom water formation, and the ability for the Southern Ocean to take up carbon dioxide from the atmosphere. As you reduce sea ice, you can also get more erosion and more turbulence because you get larger bodies of water with a longer fetch, as we call it, a distance over which winds from storms can go. And the waves get bigger, and you can have more turbulent and more energy. And that also, not only the thermal haline circulation, the circulation from lower down, but also the energy next to the coast can impact melting of those Antarctic glaciers. And one of our big concerns as far as global impacts is these glaciers, particularly the Thwaites and Pine Island glaciers, which skirt the Southern Ocean, they have the potential to melt really quickly. If you get more warm water under these glaciers from the ocean and melting them, that melt can happen really quickly. And as a consequence, we can see dramatic changes in sea levels, which impacts the globe.
Dr. Laura Landrum is a project scientist at the Center for Atmospheric Research in Boulder, Colorado. She spoke with the Best of Our Knowledge's Madeline Reynolds. I'm Lucas Willard. New York Governor Kathy Hochul has included more than $13 million in her executive budget to support a statewide ban on cell phones in schools. The Democrats' proposal would give local districts discretion on how to keep phones and other devices out of the hands of students from bell to bell. New York's largest teachers' union is backing the effort. I spoke with New York State United Teachers Union President Melinda Person about Hochul's plan.
We have been hearing from our members for a couple of years now that cell phones are a real challenge in our classrooms, especially since we came back from COVID. Our students are showing up distracted by constant notifications. We're seeing kids, gaming during the day, using social media, and hearing about kids' inability to focus on learning while they're at school. And so we started talking to folks about a solution probably a little over a year ago, and the momentum has been growing since.
Now, Governor Kathy Hochul has included money in her budget proposal for school districts to use to find a way to keep the cell phones out of the hands of students from bell to bell, as she puts it. Is there a particular method that NYSA is in favor of, whether it be pouches or a locker? Is there a particular strategy that NYSA prefers to restrict cell phone use at school?
We are not wedded to any particular strategy. I think what's important for us is that it's a bell-to-bell solution, so that it's not something that where phones are in and out of the classroom during the day, and that it does not become something that our educators have to enforce in individual classrooms, the collection of devices and then the disbursement of devices, because that is a real challenge.
How has that individual classroom, as you mentioned, how has that, patchwork up until now maybe not been effective? Where have teachers been met with resistance for those who want to restrict the use of cell phones in school?
What I've heard from our members is that it has really led to a loss of instructional time, because it takes time at the beginning of class to collect everything and then time at the end to redistribute. Then there's the time of, if there's not a consistency across the building or the district, there can be struggles about, but in this class, I'm allowed to, right? So that's why having a uniform statewide and building-wide and district-wide policy is so important.
Now, what about the concern that many parents expressed, and even Assembly Speaker Carl Heastie has said, I'd like to have my child reachable in case of an emergency?
And I think the governor's proposal does address that and requires all districts to have in place a way for parents to reach their kids. And I think the speaker was specifically referring to sort of the travel time between home and school, which I can relate to. And I think this policy only talks about during the school day while they're in school. So parents can always call a school in an emergency or to reach their child or to get a message to their child, just like they did, when I was a kid. But the bill does specifically say that districts will have to come up with a communication plan because we do want parents to be able to reach their kids if they need to.
Now, outside of restrictions at school, does NYSUT have any guidance for maybe parents in the school community about reducing screen time? Because, we can say the students can't use their cell phones in the classroom, but screen time addiction is a real thing.
Yes, and I would say this is the first step to sort of talking about this as a broader public health issue. I would say, when our Surgeon General last year came out and said the impact of social media on young people is similar to the impact of cigarettes, right? When he drew that parallel, it started a lot of conversations in the public health community about how we as a society need to start looking into the impact of phones and social media on our youth more broadly. What we're doing here is focusing on, at least giving kids the 7 hours a day on average of time and space without these distractions.
And does NYSUT have any communications that it's sending to union members about the governor's proposal, or otherwise encouraging teachers to implement cell phone restrictions?
We have encouraged our local leaders to reach out to their district administration and start a conversation about what's going to happen locally. The governor's proposal allows for a lot of local discretion, and so we want our members to be a part of that process.
And are you confident that this is a proposal, the governor's proposal, that will make it through the budget negotiations?
I am extremely hopeful. I have not heard a lot of strong opposition from anyone at this point. There are a lot of people who have questions, specifically around safety issues and making sure that parents have everything that they need. But once we've spoken to folks who have questions and answered them and brought in law enforcement to talk about the safety issues and talk to parents about the very real data that shows the negative impact of these phones during the school day, most people that we've spoken to really come around and actually support the proposal.
Melinda Person, thank you so much for taking the time. I appreciate it.
Thank you.
Melinda Person is president of New York State United Teachers. I'm Lucas Willard. This has been The Best of Our Knowledge, episode 1791. The Best of Our Knowledge is a national production of WAMC, Northeast Public Radio. Thanks to associate producer Madeline Reynolds. The latest on all National Productions programs is available via the Airwaves newsletter and our flagship station's website, WAMC.org. Until next time, I'm Lucas Willard.